Welcome back. All right, so let's continue kind of the introduction to advanced functions, and this time around I'm going to go over, reviewing the inverse functions. When you were studying these inverse functions, hopefully in grade 11, you should have gone through quite a few examples and should have understood the concept of these inverses. Now, what I'm going to do is, for any student who really wants a much more in-depth concept in terms of these inverse functions, I'm going to put up a link directly to the grade 11 entire playlist. And in the beginning of that playlist, you will notice that I have done actually quite a few examples between inverse functions, how to find them. It's not always possible even to find them, but primarily in high school, the ones that you are given, you can kind of fumble through and figure out the inverses themselves. And I give a lot of examples there. So if you will find that this video won't be enough for you, you can take a look at those playlists and then several videos on examples that I have done. What are these inverses? Well, so the concept of the inverse is kind of useful. So what we have is we have inputs that are coming in, and then we have some function or maybe even a relation. But since we're talking about functions, I'll keep it at a function. And then we get an output. Now that output we typically designate with the letter Y, the input with the letter X. Now we have a domain, right, for the input, and then we have a range for the output which is given. Now what the inverse wants to do, the inverse basically wants to reverse the process of the function so that you get your input back. Now, why would we want to do that? Well, you watching this video is a process of basically encoding, utilizing various functions. And then it is being passed on through the web, and then re-encoded back in so that you can actually watch the video. So there's a lot of these input, outputs, and then inverses as we send information through the internet. We encode things because for security reasons, but also to kind of compress them so that they're not too big, and then we can kind of decompress them again, to get them to their original size so that we can enjoy either the videos, messages that we use, the apps, and so on. So the inverse basically kind of works like this. I'm going to go back to the table of values concept so that you get yourself acquainted with the inverse again. So whenever you have an input, so let's say the input was -3, and I don't know what this function is, although we're going to be able to kind of deduce what the function is slowly. So here's the output, and let's just concentrate just on this. So with the inverse, what we want to do is we want to take, I'm going to copy this or duplicate it, and we want to take the output, so the -27, and then I'm going to put -1. So this -1 on the function, designates that we're talking about the inverse. We're trying to reverse the process. And really what we want to do now is we want to be able to take and get our input back. So I'm going to duplicate this, put it back here, so that you notice input coming in, something happens to it. Let's say we pass it through the web or something like that. Then we have an inverse function decoding it, and then we're going to get our input back so that we know exactly what it was. So within here, so the way that it would look is this would have been a -3. So it goes straight from -3, gets turned into some output. So, and we get this input back. Now, as we do this process, so as we would continue on, so now I can move over and I can say, okay, we have now -2, gave us an output of -4, and then we want to try to inverse this and then get our input back. And then we would continue this, so what we would see is, we would basically see the same inputs coming out. Now this is the ideal case that an inverse actually exists. But it doesn't always exist, or at least it doesn't always exist for all domains. And the reason I will show you just shortly, in particular, for instance, if you think of even functions and you understand what an even function is, put up a link up above there for even functions. okay, in these advanced function process. So for even functions, you're not going to get a proper inverse back. At least it's not going to be in function form for the entire domain that we want. We're going to have to try to separate things over. All right. So the main idea is that we have, okay, so if you're thinking of ordered pairs for inverses, so we're mapping x, y, and then what's going to happen is our input to our inverse is actually y, and we want to get our x back. So really, if you have table of values or if you have a bunch of points, then it's not hard to find the inverse because we're just swapping x and y, right? But if you are given a function, it's not always easy to manipulate that function to try to get an inverse function back. So for instance, when I was talking about even functions, okay, for these inverses, so what would have happened, okay, if, for instance, our function, I'm going to call it, let's say g of x, was equal to x squared. We know everything to do with x squared, right? We know it's a parabola. I mean, it's a parent function, so not a big deal. We know exactly kind of how it looks, right? We know that it touches here at the origin. But now if you wanted to reverse this, we would run into a problem because of the fact that for the input, so for instance, if x was equal to -1 or the input x was equal to 1, we know that both of these, okay, our output would have been 1 just on its own. So if we didn't know what this function was and all we were given is this, okay, that it's some black box, -1 or 1 comes in, and then an output, okay, of 1 comes out, then we don't know how to create this inverse function to get our input back in. Because if the output is 1, then the inverse is, well, I don't know. Is it going to be -1 or is it going to be 1 as my input? And we don't know unless we know a little bit more information. All right. And this was an even function. And that's why we had a problem with that. Now, it's not always just with even functions. It can be with all kinds of different other functions that you don't always have this capability of trying to find the inverse on its own. So we can surely find kind of the inverse within here. So the inverse, if you may remember, I'm going to write this, instead of writing g of x equals to x squared, I'm going to write it like this. And in order to find the inverse when a function is given, like this, then what we do is we kind of alternate and we swap the x and y, and then we isolate for the new y. So what I'm going to do is I'm going to swap x and y. I'm going to just put x kind of bar equals to y bar squared, just so that we know that we're talking about the inverse in here. And now if I would isolate this, we would get y is equal to the square root of x. And as you know, the square root, we have a problem with negative values, right? So this only exists for positive values of these. And that's why finding an inverse for this entire thing would be a problem. All right. Now I'm going to use decimals just to show you that how we can, map this out so that you can understand it a little bit better. So let's say, my g of x is equal to x squared. Okay. And now my inverse, all right, so I'm going to call my inverse, let's say h of x, okay, is equal to, but now it's the square root of x, right? And if I really wanted to try to find it for all domains, so the way that it is written, this is just for the positive inputs that I have done. Because the negative inputs, okay, are going to give me a problem in here. But if I wanted to write it out, you may remember you can do that. You can say, let's say gh, I don't know, let's put this m of x, okay, equals 2, and then we could have done the negative side so that we get the full parabola back. And for inverses, they're always reflected in the line y is equal to x. So there's going to be symmetry along this line. And you should remember this from grade 11, again, because it's just swapping x and y as your inputs. This is exactly what we have seen in here in the table of values, right? You're just swapping the ordered pairs. So if you swap them, that's like a reflection in the y is equal to x line. That's what you will notice, we will see. All right. So that's what I wanted to point out here, that, you know, these inverses. So for this, okay, for instance, we could separate this into two kind of things. We can take the positive side, and then indeed, you know, it's going to look like this. Well, I'm going to block this off right there. That would have been for the positive side, okay? And now we can take the negative side. So this would have been, let's say, this side. And for that, we need the negative. And if I go back in here, you know, put this back in there, and then that's what would have been. And here you have to, again, kind of redefine your domains and your ranges. So x squared has a domain of basically all real numbers, but its range is 0 and everything above. Now for your inverse function, okay, here you have to be careful how you define your domains and ranges for these. So for instance, what you would have is, you could have divided it into this. You could have said, okay, well, I'm going to take first g of x is equal to x squared, but I'm only going to take this, okay, for all x, such that, okay, x is greater or equal to 0, and that's this yellow that I highlighted. In this case, if I want to find the inverse, which we called h of x, okay, or more appropriate, so in here I can actually write it out, so I can say g inverse. All right, now in this case it would have been square root of x. That's my inverse, but I have to again be careful here. So I am taking the positive side in here, so that would have been that, which is fine for this, but I also have to include the range. And now the range, okay, within here, so this would have been my range y, and that y is actually anything above, right? So this would have been y equal to 0 or above. Because if you go back to the diagram, okay, or at least the graph, so that's what you will notice. The blue line, let me remove this y is equal to x, okay, and then let me remove that. So notice that the range is everything above. Now, if you wanted to define the bottom piece, this will really depend on how you're setting it up in school. So if I define the bottom piece, so now in this case, what I would have said is, so I'm right here, okay, I would have changed this and I would have said, well, here, let's define it, okay, for, let's say, less than 0, or equal to 0 as well. We just maybe don't want it necessarily in both, so I'll put less than. And then in this case, you know, we would have had to put a negative right there for the inverse. Okay, it's still greater than 0. However, we're taking now, so this, okay, would have been that. And then I'm going to remove this equal. So notice it's on the negative side. So now I have defined the bottom piece. So instead of this, I am taking that. So these inverses are not always very easy to be able to kind of manipulate, but you do have to get comfortable. The ultimate thing is, it's simple enough that you understand that an inverse is just trying to reverse the process of your function to get your input back. Okay? And that's like swapping the ordered pairs, if you have ordered pairs. Those are the easiest situations you can run into. Unfortunately, for functions, for example, that are like even, or that do kind of sway over and have kind of your outputs at the same level. So you would have, you know, if you ran into something like this where a function was, let me draw this out here for you. You know, let's say a function was something like that. All right, and then it kind of took off in here, took off in there. So notice it has multiple, so here, here, and here. So here's as multiple zeros. okay, as your output, but it happens from 3 different inputs. So good luck trying to find which one it was unless you were given more information. So because what would have happened is, let's say that this happened at -2, this happened, let's say at 0.5, and this happened, this is for the values of x, say this happened at 3. So those are my inputs. My output is the same, it's 0. So now when I have 0 and I try to put an inverse function back, right? Well, from my ordered pairs is like, okay, well, if there's 0, which one will it be? Is it -2? Is it 0.5? Or is it 3? So we know that the actual function won't exist in the true traditional sense, that it can't be defined as a function. But, you can piecewise this if you knew more information, like we did with x squared, where you divided it to the positive side and the negative side. So in here, you would have to do something similar to redefine your domains and ranges and then go from there. But if you didn't know these, then you can't really say much. All you would be able to say is you would know that the input 0 basically maps onto either this, 0.5, or 3. And you don't have any certainty on which one it was, which is a problem. Right? This is not something we want to run into when we send our information over the internet, okay? And then what the information we get back, okay, when the decoding, okay, or the inverse function is unsure what to give you back. We want them unique. All right? So that's something that you can think about. Now, if you went back to this one, okay, so in this original one, I wonder if you would guess which function this was. Now, if you do a little bit of thinking, you might have noticed that this was actually x cubed. All right, so that's what's mapping it from here to here. Now, x cubed is an odd function, and therefore, so my inverse, okay, is unique. Unlike the square root, in here, I can have negative values underneath the radical because I am taking the 3rd root, right? So when it's odd, it's fine if it's actually negative under radical. And that's why we have a unique function back. So if I would plot this for you, if you would see this, okay, I'm going to remove these from the plot, okay, and I would put these in here. So instead, so let's say we had x, I'm going to just put x cubed, right? Y is equal to x. Let's do it like this. All right, it's supposed to be reflecting in this, okay, right here. And now let's take a look. I'm going to go to functions. Let me find somewhere there. There we go. So we want the 3rd root. All right, and notice the beautiful symmetry along that y is equal to x. And the blue that you see is the inverse. So if I hide this away, that would have been the inverse that we had. And it is unique. It's actually for odd functions, it will be unique. Okay, so that is kind of the review concept of these inverses and things that you want to think about. Okay, now I have 2 other examples for you, which is going to make the video a little bit longer for those who don't like it, I guess tough. But, here let's kind of review back and let's challenge ourselves to try to see inverses from some of the common functions that you probably have studied in grade 11. So here's a quadratic. Now, quadratic is basically just a parabola, right? And so this is going to be a transformed parabola. So it's going to have a vertex at a different point, and probably scaled slightly differently as well. So let's take a look at this. So how would we find the inverse function? So I just want to give you some kind of a sense when it's a little bit harder than just a parent function that you're dealing with. So in this case, for quadratics, we can always find kind of the inverse function, okay? And for that, again, it will depend on the domain that you're taking. So in here, you may remember that if you wanted to take this, to plot it, it's not a big deal. We can plot it, we can use decimals, But if you want to find the inverse, my suggestion, as I mentioned in grade 11, is with these quadratics, is complete the square, put them in the vertex form, and then from the vertex, you can actually manipulate it to find the inverse. All right, so let's do that. I'm going to do that in fast forward fashion, okay? So for those who, want to know, is all I'm doing is completing the square. And you can find that information in grade 11 content. All right, so I can put up a link above there in case you forgot about completing the square. So here it is. I just completed the square, so this is my f of x. I'm going to put y here, okay, just so that it's a little bit easier. Now, I can certainly graph this, so it's not a big deal. We know what the vertex is, right? This is just transformed parabola. So, we're scaling by 3, so that means we're just going to be stretching it out, and then we're just kind of shifting it. So it's going to be, I guess, -2, and then -14 down, and the parabola is going to look up. So I'm going to plot it on decimals in just a moment. Now, once you have this, so again, if you want to find the inverse here, and so anyone who gives you kind of a function which hopefully is doable in some way, so what you do is you're going to swap these, right? We want to be able to swap these, and then we're going to be isolating for our new y. So I'm going to swap them. It's going to be 3. This is now going to be y. All right, and now we're going to want to solve for this. So now let's solve this. It won't be, for quadratics, it's not very hard. So let's bring that 14 over. Okay, bringing that over to the side. Then next I'm going to have to divide by 3. All right, so first I'm going to bring this over. Then I have to get rid of this 3. So I'll divide both sides. So that's going to leave me with this, just so that you can see. Now to get rid of this squared, so this is where your exponent comes in, so your rules for solving. So now we're going to take the square root. So it's going to be the square root of that. And this is where the problem is going to come up, because this is going to be plus minus, right? So because for quadratics, and then so that's going to be y plus 2. So let's move that plus 2 now over. It's going to be minus 2. And here is your inverse function. And now you're going to have to define your domain, okay, and your range for this as well. Okay, so if you want to make it complete, I'm not sure how your teachers will want to do it, okay? And so let's take a look at this and try to graph it out. So I'm going to take, either this or this, it doesn't matter. Let me bring this up. All right, and actually I'll split it in half. Let me do this. Okay, so let's plot that original. So this would have been f of x equal to 3x squared plus 12x minus 2. Okay, so this should not surprise you. Okay, we know what the vertex is. It's going to be -2, -14. All right, so that's that. Okay, so we plotted it. Now, the inverse is going to be, okay, a reflection in this line that we have. Let me make this bigger so that we have it in there. And so what that means, it's going to kind of get, shifted in this way. And here is where we're going to have to, be careful. So because we are, so this is -2, -14. So if you, again, inverse, that means you're just swapping the ordered pairs, right? So my new vertex, now it's going to be kind of on sideways. It's going to be -14 minus 2. And from there, we're going to draw our parabola in, which is really the square root function. So it's going to be on the positive side, or at least from the point -14 onwards. It's going to go up. There's 1/2, which is going to be there. And then we're going to need to do another one, which is on the negative side. So let's do that. So this is, okay, so square root, and this is going to be x plus 14 All right, divided by, and we want the whole thing to be divided by, so let's put this in bracket, x plus 14 divided by 3, okay, and then we want minus 2. So when we do this, so notice we're only going to get half of it, and so this point, okay, is at negative 14, 2, which makes sense to us. Now if we want the other half, you're going to have to redefine this and put the negative side as well. So it's going to be the square root. Okay, so we put the same thing. So x plus 14 divided by 3 minus 2. But in front there, we have to put negative. And we get the bottom piece. And you can see the domain is basically negative 14 or bigger. Okay, for both of them. And for the upper half, we are from negative 2 to infinity, so above negative 2. And for the bottom half, it's going to be less than negative 2 down. That's for your range. All right? So that's an example that you would see. So it's an inverse, and if I'm going to blow this up, you can see this the nice symmetry, okay, in here. Let me, do this and try to... Okay, so there you go. You can see the nice symmetry along y is equal to x. Okay, now you can of course do this with others. Here's a final example that I'm going to put in here. So this is a cubic. Now when it's cubic, we know that the parent function is a cubic and it's an odd function. So we know that this is going to have a unique actual inverse. So we won't have to, worry so much about trying to figure out, and especially when we're plotting. So I just want to show you another example like this. And again, in the beginning of this video, I recommended a playlist from grade 11 if you want to see a lot more on inverses. So for this, okay, cubics, so basically are defined for the entire domain. This is why understanding those parent functions was so important. Again, parent functions, review, okay, take a look if you're studying these advanced functions. So here, what I'm going to do is, again, so I'm going to just go y is equal to negative 2, x plus 1 cubed plus 2. Now, if the cubic was an expanded form, then it becomes annoying, and you may not be able to find a nice inverse. Here, it's actually not an expanded form. It's actually in kind of that transformation form, which makes it so much easier. All right? So don't feel bad if something is expanded, especially if you start talking about, x to the 4 or x to the 5. So the order gets higher and higher, and it's an expanded form. Good luck. Just let the beautiful, decimals or other software, help you in those instances instead of you struggling, okay, throughout. So don't feel bad. I myself can't find many inverses. There's only some inverses that you can do by hand. The rest you need, software tools. Luckily in high school, you typically are dealing with inverses that are possible, all right? So how would I find this one? Well, so if I'm going to be swapping these out, so I have to swap it to find the inverse. So this is going to be y, and I'm going to be isolating for y. So it's going to be x minus 2 divided by negative 2. That's from here. This 2 got shifted over. And I don't want to skip too many steps for you. Now we have to get rid of this. So we're going to have to take the cubed root of x minus 2, negative 2, and then shift this 1. So it's going to be minus 1. And that's your inverse function. So here, since it was g, I can just call this g that, and that's your inverse. And here you will notice that because it's cubic, again, this was really, so it looks like it's negative 1, so it's shifted to the left, negative, so 1 to the left, up 2. That's from the transformations and understanding that. Negative 2 in front, So that means it gets stretched out, and also there is a reverse, right? That's why understanding those transformations is so super useful, okay? Okay, so now to graph it, let me go back in here. Again, I'll try to split it just so that we can, I'm gonna hide these away, and this will be it. Okay, so here's the original. So let's put that one in. Sorry, negative 2 x plus 1 cubed plus 2. All right, so notice, so this is what I said, right? It was shifted negative 1 and up 2. Okay, so that's my point there. Negative 1, 2. Okay, that's where it kind of gets shifted, and it again, and then it gets stretched out. So let's see. So it's kind of, looks like that. And notice the reflection because of the negative 2, because the regular cubic would have looked like that, right? It would have went from bottom through 0 up. This one kind of goes from this way because it's negative 2 in there. The inverse, so let's do the inverse. So again, I'm going to go to the functions somewhere at the bottom. So here, this is the third. And so here, let's put it in brackets over negative 2 and minus 1. Okay, so we'll do that. Well, this is not very helpful, but let's see. And scale it. We have to kind of scale it so that it does. All right, so here it is. Let me shift this over. And then you can pick off the domains as needed. Okay, so here it is. So this is what we have. And if you want, here's your symmetry line. So once you draw the symmetry line, you can kind of see. All right, so the blue one is the original. The green one is the inverse. So that's a review of inverses for you. One of the definitely harder topics, especially as you're going into domain and ranges and understanding that. Inverse itself is not bad, right? Swapping the ordered pairs. But once you're given functions, then it becomes sometimes difficult. All right, so thanks for watching, and have fun in your advanced functions course. Bye, everybody.